Hey class, Mr. Sule here, and hopefully you're using your vacation time wisely and getting some work done in preparation for our return to school in 2023. The problems that are on the sheet, there are 16 problems, and you have 8 days between the 26th of December and the New Year. If you do 2 of these a day, I don't think it's going to take you very long, maybe 10 or 15 minutes. And that would be about 2 hours of review that you wouldn't have to redo once we return. So here's to all that. So let's take a look at question number 1. I always like doing a visual of what we're dealing with. It looks like there's a piece of paper, and it says it's 8.3 centimeters on one side and 7.4 centimeters on the other side. Now, if we look at significant figures here, there's 2 in each of those. That's pretty straightforward. And it says, what's the area of the paper? So remember that area, the formula of that is the length times the width. So I'm going to substitute 8.3 centimeters. I'm going to multiply that by the 7.4 centimeters. And my answer then is going to be in centimeters squared. And I'm only going to be allowed to have 2 significant figures. Now, 7 times 8 is around 56, so it's going to be a lot. Plus, there'll be some decimals in there, so we're going to have to do some rounding. So let's go to the calculator, and it looks like 8.3 times 7.4 equals 61.42. And then we go back here and we say, okay, the unrounded is 61.42 centimeters squared. And since the least number of significant figures is 2, so I'm going to round out the decimal part there. And then I'm going to write this in scientific notation, which would be a 6.1. And I moved the decimal place 1 place to the left. That would give me a 1 there. So here's my final value. Times 10 to the first square centimeters. I circle that. I double check my work. It looks pretty good there. Okay? All right. The perimeter of the paper then, if we look at this, it's going to be each of these different lengths added together. There's a different rule with significant figures when you do addition and subtraction. Okay? So the perimeter is going to be 2 times the length plus 2 times the width. So that would be 8.3 plus 8.3, everything in centimeters, 7.4 plus 7.4, everything in centimeters. And then if we look at what's the smallest part of each one of these measurements, they're all measuring to the 10th. So you can express your answer all the way down to the 10th place. That's the difference with significant figures with addition and subtraction. If one of them was missing a 10th, then you couldn't do that. All right, let's go back to the calculator. Let's go 8.3 plus 8.3 plus 7.4 plus 7.4 equals 31.4. Bring that back over here, and it looks like the final value is 31.4. And it's centimeters since we're not multiplying or dividing any units. And it's got that smallest place is acceptable because they were all measured to the 10th. So I'm going to circle that. And there's the perimeter of the piece of paper. All right, for number 2, in scientific notation. Now remember, in scientific notation, you have some number that's between 1 and 10, but usually less than 10. And then you've got it raised to some value of an exponent over here, okay? And it's going to look in that format. So that means I'm going to have to move this decimal place over 1, 2, 3, 4, 5, 6. So it's going to be 1.42. And then if I go and I look at how many significant figures there are in the way that it's written, there's no decimal place. It's assumed there's a decimal place, but it's not written there. And there's no zeros to the right of the decimal place. So all these zeros then are acting as placeholders. Okay, so they're not significant. So this number has 3 significant figures, the way that it was written. So I'm going to put that answer in 3 significant figures. And I moved the decimal place over, oh gosh, I forgot, 1, 2, 3, 4, 5, 6, times 10 to the 6th, and the units are seconds. And then I'm going to circle that. And it looks like I've got the right number of significant figures. Okay? Your calculator will do that for you. Okay? It won't do the sig figs part, but it will do the moving of the decimal place. If you need help with that, let me know. Okay, for the next one, I've got to move the decimal place into this position here. So I'll be moving the decimal over 1, 2, 3 to the right, 8.09. And I moved it 3 places, but since I made it look 3 times bigger, then I'm going to have to put a negative sign there, and I leave the units of kilograms. Okay, once again on the sig figs, leading zeros are not significant, so these zeros that are there are only placeholders, and it would look weird to put zeros out in front of the 8. No. Leading zeros, they don't count. Trailing zeros that involve no decimal place, then they also don't count. Here's another one that has a whole bunch of trailing zeros. All those trailing zeros aren't going to count. These values do count. So you've got 3 significant figures here, and I'm going to have to move my decimal place between the 5 and the 0. So I'm going to have 5.01 times 10 to some value, and it looks like 1, 2, 3, 4, 5, 6, 7, 8. Oh gosh, that's a lot. Times 10 to the 8th. I made it look 8 decimal places smaller, so I have to take that up with the 8 as a positive value. And there's my units. Okay? These are all done. Good job with those. Okay? So, move on to number 3. And here's where we're doing a calculation using significant figures again. It looks like each of these have 1 significant figure that's there. And if I'm going to put that into my calculator, let's go to the calculator here. And it looks like the numbers I'm going to plug in. Now this is a little bit different on your iPad calculator. It's 2 EE, and there's the 6. Okay, and when I hit the times button, then you notice that up in the right above the 2 million thing there, it shows 2EE6. I'm multiplying that by 5 EE5. Okay, and when I hit the equal sign, it shows that right above this, and now it's a whole big giant number, and this calculator won't put that into scientific notation. So it looks like I've got 3, 6, 9, 12 decimal places. So let's go back here, and it was going to be 10 times 10 to the 11th power, but when I move that last place over, okay, it gives me a 1 times 10 to the 12th power, and we're multiplying meters times meters. So as in an area, it's going to be square meters. All right? So I'm not sure you'd even need a calculator if you're pretty good with numbers. Okay? The thing that would throw you off, 2 times 5 would be 10. The 6 and the 5 added together give you an exponent that's 11 meters squared. And the awkward part in problems like this is that these two values, they represent the same amount. But this is why we always try to convert to scientific notation, so that in scientific notation, we'd be comparing numbers that always had the first part of it in a number between 1 and less than the 10 that's shown here. Those are the same number value, but they don't look the same. All right, so let's go, let's look at B. And in B, I'm going to look at sig figs here. I've got 2 in the first measurement. I only have 1 here. So I know in my final answer, I'm only going to be allowed to have 1 significant figure. That's probably going to involve some rounding. All right, so we're going to go back to the calculator and plug this in. So here's my calculator. You really need to have your savvy up on or have your skill set all working on your calculator, because your iPad calculator is not going to be available. Okay, 1.2 EE7, And then I'm going to divide that. You notice a 1.2 EE7 shows right above that value. Divide that by 4E2. EE2. We go equals, and it looks like the number value is 30,000, but we'll have to do some converting to scientific notation. So if I write down the 30,000, then putting that into scientific notation, then it's going to be 3 times 10 to the 1, 2, 3, 4, fourth power, and the units of meters divided by seconds, meters per second or divided by seconds, and the number of significant figures should be 1, like we saw here. So it looks like I've got my answer in the proper number of significant figures. All right. So for the last one here, this is an addition problem, and this one's tricky. You got to be careful with some of these addition problems because the numbers get a little bit confusing, and it's a different rule. So I'm going to take it out of scientific notation. This number here is 506. And then I'm going to add this to this number here. And this looks like it's 8.124, but there's a K here. And if you don't catch that, you'd add these together. You'd get like 514. But that K means that there's 1,000 meters represented by that K. So really, this is 8.124 times 10 to the third meters. A kilometer is 1,000 meters. So if I move that decimal over and write it again, now I've got numbers that look like this, all right? And in addition and subtraction, what I'm always going to suggest that you do is that you line up the decimal places in each of these, 5,000 or 506, 8,124, and then you do the arithmetic, 2, 6, 8, and it looks like there's nothing recorded in the tenths place on either of these, so I won't have anything recorded in the tenths place in my sum of those. But then I've got to put it back into scientific notation, which means I'm going to put the decimal place back between the 8 and the 6. So if I clean this up a little bit, 8.620, and I moved it over 1, 2, 3, and the units that I was dealing with was meters because I converted the kilometers into meters. So there's my answer of the number of meters that are there. All right, let's do one more on the next page here. Oh, there's 2 parts to it. Great. Okay. All right. So on number 4, then this is one of those dimensional analysis problems where you put the train tracks in. I'll set that up in advance. Oh gosh, that's a nice straight line. And remember that you're going to be putting the given value in the top parts of this. So I've got 55 kilometers, and here's where some people mess up. They see this /h and they try to put it up into the numerator. Oh gosh, don't do that. It'd be really hard to get the right answer. So you're going to put the per 1 hour in the denominator of that dimensional analysis. Now, to get me to meters per second, I've got to get out of kilometers, so I have to know some sort of relationship between kilometers and meters. And if I go to my chart that has all the conversions that you'll have access to, there are 1,000 meters equals 1 km. That's an important conversion factor. And then you also have to convert from hours into seconds. And on your conversion factor, there's a direct conversion of 3,600 seconds in 1 hour. Okay? So if you drop those 2 conversion factors into your dimensional analysis, then we want to cancel kilometers. So I'm going to put km here, and I want to introduce meters in the numerator. So I'm going to put the meters up in the numerator. So it's 1,000 meters is 1 km. And then when I go through and I look at these factors of the units, I cancel out kilometers, which are not in my answer. Great. I've got it to meters there. Okay. I need to cancel out hours, so I'm going to have hours in the numerator since it's in the denominator to begin with. And then I would introduce seconds in the denominator, and my conversion factor is 3,600 seconds in 1 hour. And hours then will cancel with hours. And the final units that you have remaining are meters in the numerator, seconds in the denominator. Check, check. Okay, so then I'm going to go to my calculator again, and I go 55 times 1,000. And then I hit equals, and then I divide that by 3,600 equals, oh my gosh, that's a huge number, 15.277777. So the answer that I get was 15.2777. You're not going to need all those decimal places because this number here determines how many decimal places in your final result. This one has 2 significant figures, so I'm going to go to 2 significant figures here. 15 meters per second. Now that's really close to 10. That probably would be an easy thing, but if there wasn't this answer on the answer key, the ABCD key, it might be written like this, and hopefully you would realize that those are the same value. 15 is the same as 1.5 times 10 to the first meters per second. Okay? If this was a paper test, either one of those answers would be acceptable because they're both really close to 10. All right, the last one is another conversion. So let's get my train track set up here. Nice long one because it's going to have a few more values that are in there. Okay, so it looks like I've got 55 kilometers per hour. Oh, that's the same starting thing. Value, that's the given. 1 hour goes down below. And then I've got to convert this into miles per hour. Okay, so there is no conversion for the denominator. I don't have to worry about that. But I am going to have to get rid of the kilometers and introduce miles here. Okay, if I go to my conversion sheet, it will say there's 1,609 meters equals 1 mile. But then that doesn't get me out of kilometers. That only makes meters into miles. So I'm going to be using this conversion factor and then this conversion factor because I've got to get out of kilometers into meters, and then I'm going to get out of meters and into miles. So that will allow all my units to cancel out. Kilometers, meters, and then what I have left over is miles in the numerator, check. Hours in the denominator, check. And then I plug in my conversion factors, and there are 1,000 meters in 1 kilometer and 1,609 meters in 1 mile. It'd be really easy to get those inverted or flipped over or upside down if you were not careful in following your units. Okay, that's why we take pains to set that up so carefully. All right, back to the calculator. We go 55 times 1,000 equals, and then I'm going to divide that by 1,609 equals, and I got another big giant number, 34.18, blah, blah, blah. So let's go back, and we'll say the final answer, 34.18 miles per hour. All right, and it looks like once again we have 2 significant figures to begin with. So these values then are going to round out, and you'd have 34 miles per hour, or 3.4 times 10 to the first. miles per hour. And this is in proper scientific notation. But once again, 34 isn't that far away from having a value that's close to 10. Okay, hopefully in the couple days that you spent on this, your answers come out looking like this, and check in later. I'll have more answers posted in a few days. Thanks.